Good day, welcome to Math Made Easy. Still under numbers and numeration, we'll be doing fractions and decimal. Let's start with fraction. Now, fraction, whenever we have fraction, most times it's supposed to look like this or like this, right? It means that you're supposed to have your numerator and your denominator, right? When it is like this, we know this way is your numerator, this way is your denominator. Here it's known as what? The whole number, right? Known as the whole number. So this is basically how a fraction should look like. So in doing fraction, we have types of fraction. We have proper fraction, we have improper fraction, we have mixed fraction, we have equivalent fraction. Now, proper fraction is when the numerator is smaller than the denominator. We have 1/2, 3/4, 5/7, and so on. When the smaller number, which is the numerator, when the numerator rather is smaller than the denominator, it is a proper fraction. An improper fraction, it is the opposite. It is when the numerator is bigger than the denominator. That's when we have improper fraction. For example, we can 4/3, 7/5, and so on. This is an improper fraction. It is when the numerator is bigger than the denominator. Now, mixed fraction looks like this, right? Mixed fraction, you have your whole number, you have your numerator, you have your denominator, and most times your mixed fraction actually comes from your improper fraction. So if we have 7/5, the mixed fraction will be 1/2/5, right? How do we do it? Let's go back to primary school or junior secondary. 7, 1, 2, 3, 4, 5, 6, 7. Forgive me for doing this, but I really want everyone to be able to grab it. So how many 5 can you see? 7, 1, 2, 3, 4, 5, 1. So we cannot see another 5 there, right? So we have 1. So this one will act as the whole number 1. What is the remainder? 2. And what is the fraction? The denominator, bring it back 5. So that's what improper fraction, mixed fraction rather, mixed fraction. Mixed fraction, we derived it from improper fraction. So if we're deriving from this 4/3, what will it be? Yes, you're right. It will be 1/3. So we can have 2/5/8. We can have 14/2/7, and so on and so on. It goes. Equivalent fraction is just the fraction, the same thing, but there is something different. What is different? Let me pick one, for example. Let me pick this 1/2. An equivalent fraction of 1/2 is what? 4/8. Now, what is the difference? Is this one that this one is reduced to the lowest form? This 4/8 is still 1/2, right? But they are in the multiples of 4. So in the multiples of 5, we can have what? 5/10. This is an equivalent fraction. Do you get it? So we can have also, let me do 3/4. 3/4 here. We have 12/16. Multiples of 4. We have 21/28. Multiples of 7. So this is an equivalent fraction. All right, quickly we will be doing decimals, and in doing decimals, we quickly want to just look at decimals. Now, decimals, for me to simplify decimals, I have to go back to place values. Because there's something we need to understand. If I'm having 1, 2, 3, 4, 5, 6, 7.89. Let me add 2, 1. Let me just add it. Now here we know that our unit is the last one. We have the units, right? If you want to count it, you do your 1 2 3 1 2 3, right? We have the units, tens, hundreds, right? Thousands, tens of thousands, hundreds of thousands, and we have the million, right? But when we are going after the points, decimals means you have something with the point. You have a number that has a point. It is a decimal number, right? But they cannot tell you one decimal place. That's when we are doing approximation. They cannot tell you one decimal place, two decimal place, blah blah blah, and so on. So, but whenever you see a number with point, it is a decimal number. It doesn't have to look like this. It can be 0.82. It can be 1.04. These are decimal numbers. Now, in looking at decimal numbers, the place value of this, right, is the same as this. Now here you are going tens, hundred. Here you are still going the tens, hundred, but it's not tens now. It is a decimal, so it will be what? Tenths. So now normally this one is written as TENS, but this one will be written as what? TENTH. Tenth. So this one is written as hundreds. This one will be written as what? Hundreds. Like that, thousands, tens of thousands, like that. So that's how a decimal number should look like. And when you are calling decimal numbers, whenever you reach the point, you don't try to do something like this. You call it 11. For example, we have 1,234,567.8921. You don't say point 8,009, no, 0.8921. That's how a decimal should be. So we'll be quickly doing addition and subtraction of fractions and decimal. Addition and subtractions of fractions and decimal. Now, if you are adding a fraction, most times fraction is added with. Let me just do a few examples. 3 over 4 plus, why do I like 3 over 4 like this? 5 over 7, 3 on number 2 over 3 minus 1 on number 1 over 2, right? And we have 4 on number 7 over 8 minus 2 on number 2 over 4, right? And we have number 4. Let's do just 5 examples. Number 4, we have 4.212 plus 3.42. We have 742.31 minus 374.422. All right, so these are the examples we'll be taking. So now we know our LCM. In solving this one, first thing first, 3 over 4 plus 5 over 7. We look for the LCM. What is the LCM of 4 and 7? Right? It is 28. What I just did was multiply it, but most times it doesn't work that way. Most times you have to do your LCM and you get 2721711. So 2 times 2 times 7. Most times you do it this way. I think we did LCM in junior secondary school, but most times you do it this way. Now 28. How many 4 can we see in 28? We have 7, right? 7 times 3, 21, right? So how many 7 can we see? 28. 4. 4 times 5, 20. So we have 20. So it will give us what? 41 over 28. What type of fraction is this? Improper fraction, right? Because the numerator is bigger than the denominator. And if we want to change it to mixed fraction, we can say one whole number, that will be 13 over 28. That's it. Then number 2, we have 3 whole number 2 over 3 minus 1 whole number 1 over 2. Now the simple way is allow the whole numbers minus themselves. So we have 3 minus 1. What is the LCM? 3 and 2, 6. How many 3 can you see? 6. We have 2. 2 times 2, 4. Minus, how many 2 can you see? 6. 3. 3 times 1, 3. So 3 minus 1 is what? 2. And we have 4 minus 3, 1 over 6. Now this is a mixed fraction. This is what? A mixed fraction. Now doing number 3, we have 4 whole number 7 over 8 minus 2 whole number 2 over 4. 2 whole number 2 over 4. And what do we do here? We bring this one, 4 minus 2. What's the LCM? 8. The LCM is 8. Now, normally, this is an equivalent fraction, but I don't want to take time. This is 1 over 2. 2 over 4 is 1 over 2. It's just that this 2 over 4 is in the multiples of 2 of this, right? But we can still solve it that way. So, how many 8s can you see in 8? 1. 1 times 7, 7. How many 8 can you see in 4? That's what? 2. 2 times 2, 4. We get it. So 4 minus 2 is what? 2. 7 minus 4, 3 over 8. 3 over 8. So that's for number 3. Number 3. I'm sorry, I'm dividing my board. Number 4. Now, this is the way to arrange it. If you have 4.212 plus 3.42. Whenever you see that there's another number, whether this one is up or this one is down, and you see an empty number, just add 0. It's after the decimal point, just add 0. So what do? 2 plus 0 is what? 2. 1 plus 2 is what? 3. 2 plus 4 is what? 6. Right? Yes, then 4 plus 3 is what? 7. So our answer is 7.632. 7.632. Now the number 5, we see 742.31 minus 374.422. This is the way to arrange it. So, I said whenever you see there's an empty number, you add 0, provided that this one is there. If this one was not there, you leave it like that, right? But because this 2 is here, we add 0. Now we are minusing, or we are subtracting rather. 0 cannot minus 2. We cannot say 0 minus 2 to give you a negative number, right? And we cannot have a negative number from the end. If you want to have a negative number, at least it should be at this front. So we have to borrow. If you borrow from here, it becomes 0. Whatever you borrow, because we are doing a decimal system. When we go to number base, we understand what the decimal system we have. We have binary, we have octal, we have decimal, we have hexadecimal, but we are doing a decimal system. So in borrowing from a decimal system, that's a normal counting number. Normal counting number is a decimal system. So in borrowing from a decimal, we have 10, because our normal counting number is in base 10. So we are adding 10. So it's not like we're just putting, the reason why we're putting the 1 is just we are adding the 10. So we have 10 minus 2 is what? 8. Here we still have 0, so we still borrow. We have 2. Right? This one becomes 10. 10 minus 2, 8. Here is still lower. We borrow. It has 1. So that 10, we add 10 to 2 becomes 12. 12 minus 4, 8. Let me write this 8 very well. So here we are borrowing. 3 becomes, add 10 to becomes 11. 11 minus 4 is what? 7. Here we are borrowing. Yes, sir. Yes, sir. Right. Alright. No problem, sir. So continue from that. We have 12 minus 4. Rather 11. Rather, since we borrow, we're going to have 11. We're going to have what? 11. Sorry for the interruption. I'm using a school, so we have 11. 11 minus 4, that's 7. So here we still have 3. 3 is lower than 7, cannot minus, so we still borrow to give us 13. here is 6. So 13 minus 7 is what? 6. Then 6 minus 3 is what? 3. So our final answer is 367.88. I was supposed to end here, but I will just try. Let's do multiplication and division in fraction. I don't know if there will be enough time to do for decimal. But multiplication and division, we have 1/2 times 5/7. We have 2/3 times 9/4. We have 7/8 divided by 3/4, like that, and we have do 0.2 times 0.3, right? And we have 0.05 times 0.7. 0.05, 0.7. All right, so let's start from number 1. We have 1/2 times 5/7. In multiplication of fraction, is simple. Multiply the numerators together, multiply the denominators together. 1 times 5 is what? 5/2 times 7 is what? 7. Now, number 2, we have 2/3 times 9/4. I can do it in 2 ways. Either I decide to cancel, but I will not try to confuse you. So let's do 2 times 9 is what? 18/3 times 4 is what? 12. Now, we can try to reduce it in its lowest term, in the sense that we say, or let's not reduce it yet. Let's turn it to mixed fraction. Or we can reduce it here, saying that 6 can go here, plus this can go here. Well, let's reduce it to mixed fraction. If we are reducing it to mixed fraction, we have how many 12 can you see in 18? The same way I taught you. If you don't really know how to catch up with it, you can just, it's not advisable, but you can just do it. So 1/6/12. Now this is an equivalent fraction, so we have to reduce it to its lowest term, and we know that 6 can go here 1, 6 can go here 2, right? If you don't know that, you can do it 1 small. We have 1 is a common factor between every numbers, right? So we go to the next number, 2. You check, can 2 go here? Can 2 go here? Okay, yes, 2 can go here, give us 3. 2 can go here, give us 6. So we still check that 2 again. Can 2 go here? Can 2 go here? No, 2 cannot go here. Now we check the next number, 3. Can 3 go here? Yes, 3 can go here. 3 can go here. So 3 here 1, 3 here 2. So we've reduced it to its lowest term. Nothing can go again. So basically our answer will now be 1/2. So we have number 3, we have 7/8 divided by 3/4. Now in division of fraction, we work with what we call the reciprocal law. What happens to the reciprocal law? We change the divide to times. Now 7/8, this divide change to times. Now when this divide change to times, the law of reciprocal will tell you that the denominator becomes the numerator and the numerator becomes the denominator. Basically you are switching them whenever you change it to times. So we have 4/3, right? We can decide to cancel from here, or we say 7 times 4, 28/24. Do we get it? Now, how many can you see here? You see 1, 4/24. Also reduce it, 4 here 1, 4 here 7. So we have 1/7, right? 1/7. Is this 7? It's not 7, no. 4 here 1, 4 here 6 is 6. Oh, sorry for that. 6. 4 here 1, 4 here. If you are confused about it, just bring out the 4/24. 2 can go here 2, 2 can go here 12, 2 can go here 1, 2 can go here 6. So it's 1/6. Now let's do this, the last 2, which is decimal, and we are done for this lesson. We are done for this lesson. So number 4, we have 0.2 times 0.3. Arrange it. We have 0.2, we have 0.3, multiply. Now first thing, 3 multiply all, that's 6, 0. 0 multiply all, 0, 0. Right, we have 0, 0, 6. Are we getting it? Are we getting it? Basically, there's a way I usually do it. But if you don't know how to do it, right, just pick this. From this 0 part, right, you are coming to this place. 1, 1, right? That's 1 plus 1. That's what? 2. How many movements? 2 times. So you go from back. We went back, so you are coming back in. 1, 2. So 0.06. There is another way you can do it if this part will confuse you. How you do it? You change this to fraction. It's easier for you that way. How do you change it to fraction? 0.2. To change to fraction, go one time. Now we have what we call in the tens, in the hundreds, in the tens, in the hundreds, in the thousands, 10,000, like that. Now once your movement is 1, you are trying to move this point to this side. What becomes of this 0.2? It becomes 2 over, put 1. How many times do you move? 1, so you put 1 0. But if you move 2 times, it becomes 2 0. If you move 3 times, it becomes 3 0. Do you get it? So now it is 2 over 10. For 0.3, it's the same thing. Move 1, we have 3 over 10. So multiply it. 2 over 10 times 3 over 10. We have what? 6 over 100. You can leave it a fraction. And if you want to bring it back to decimal points, whenever you are dividing by 10, 100, like that, how many zeros? The same way you remove the 0. 1, 1. So how many zeros is there? 2. So from this back, you are coming inside. You move 2 times. 1, 2. Right? Where you stop, you will now put your point. You put your 0 here. But before the point, there have to be a 0. So your answer is what? 0.06. If you don't still grab it, just leave your answer in fraction. But try to practice more. The more you practice, the more you get the hang of this. Now we do number 5. Number 5, we have 0.05 times 0.7. So we have 0.05, 0.7. So 7 multiply this. We have 7 times 5, 35. 5 carry 3. 7 times 0, 0. Bring down your 3. 7 times 0, 7. Then 0 multiply here, 0 multiply here, 0 multiply here. Add it. We have 5, 3, 0, 0. Now move 1, 2. You move 1. How many times? 3. So you are moving back 3 times. 1, 2, 3. So our answer is what? 0.035. Likewise, we can do 0.05. You move 1, 2. It becomes 5 over what? 100. 0.7. You move 1. It becomes 7 over 10. So you say 5 over 100 times 7 over 10. We have 35 over 1000. Now bring your 35. How many zeros are here? 3. So we move 1, 2, 3. Put your point 0. Put your point here. 0.035. Alright, we are done with fractions and decimal. So see you in the next video. Please like and share the link.